This is going to play into the reasoning for today. So today we're going to do stuff with interest, specifically compound interest. But this relatively lower thing that you should have access to is going to be the reason why what we're going to do next works, all right? So we're going to focus on the why. So we have Andre and May, and they, for a group project, they're scaling up the images. They have two of the same images. So Andre scaled it up 10%, said not enough, scaled it up 10% again. And May said, cool, I'm going to make mine match. I'm going to scale it 20%. It's your job to decide, are their images going to be the same size, yes or no? And you need to be ready to justify that. You can't just make a guess, right? You have to be ready to justify it. Let's go. Who's got an answer for me with the justification? And what you thinking?
No.
You're thinking no, why?
I put in my calculator 5 times 1.1.
So you decided to pick a side length 5?
Yeah.
Okay, so, and you did times 1.1 times 1.1, what'd you get? 6.05. And then if you did 5 times 1.2, you got, ooh. So I like that. Evan's imagine this side length. I did something pretty similar to say no. What I said is 1.1 times 1.1, which is what I would multiply by regardless of what it is 1.21. And that is not equal to 1.2. That's kind of what so same idea. I kind of like that you picked a theoretical side length to test. So who can tell me why then? What's happening with the math in the situation that's making it not match? So we did some math to it. We found it doesn't match. Why is that, Emmett?
Well, the thing that Andre did would be it would scale up to 10% and then scale that image that's already increased by 10% again.
Yeah.
So it's not 20%. It's more of 10% than 10%.
Yeah, so he established a new total, then applied 10% to it, which would give us a bigger outcome. So this is called compounding. And that's what we're going to focus on today. So that method of the repetitive nature of it not being the same thing as compounding. It's also similar to the reason, if you have $100 and you lose 20%, but then you add 20% onto that,
That's not going to be 100.
it's not back to 100. Similar reason, right? Because your percent's applied to a different whole. Okay.
Same thing as if you have $100, you lose 50%, you lose another 50%, you're not going to be at $0.
Yeah. Yep. Our whole has changed. So we're going to apply it to this. You guys are going to focus on problems 1, 2, and 3. Okay? So there's a bank account. You put your money in this bank account, and it's actually a really good one. You have $1,000, and your bank account earns 1%. But here's a little change from what we've looked at. It's 1% each month. Okay? So 1% monthly. It's your job to find out how much money we have for those years. Okay, hey guys, we're going to stop that side conversation. Then what I would do though, you know me. I would actually swap these two things. You don't have to, right? I would start with the function because I don't want to do 1.01 times 1.01 times 1.01 times 1.01. 5 years, how many times is it going to compound?
12 times 5.
12 times 5 or 60, right? So that's a lot of things to do. I suggest doing number 2 first, but you don't have to. So with your partner, you're going to look at getting through 1, 2, and 3, and then we're going to discuss 4 together. So again, like I said, you know me, I'm going to go out of order. I'm going to get the function first so I can use the function. So for problem number 2 on here, I've got A equals, what's my initial value?
1,000.
It's 1,000. What's happening to it, everybody?
1%.
So 1.01 to the number of months.
6.
So, this wants m months. Okay, so this is the function I'm going to use for my 6 months, 1 year, 2 years, 5 years. So for 6 months, I'm going to put 6 in for m. And that means after 6 months, $1,061.52. For 1 year, instead of putting a 6 in my exponent, I'm going to put 12. 1 is the most common wrong answer there because people will just not think about it. Make sure you think about it. So 1 year I have $1,126.83. Next I'm going to do 2 years. So instead of 12 months, I have 24 months. And that gives me $1,269.73. And last up, we got 5 years, which is how many months? 60. And that's why I like this calculator I'm using because I can just go change my exponent. 1,816.70. Okay. So you can see again, if you put money in an account and let it sit, what does your money do?
Grows.
It grows. It makes money.
It depends though, because like if
Some-
you put money in a savings account, it depends how much inflation is happening.
There is inflation. So this one, 1% each month for a year, it has this. So you're going to want to write this down. This would be 12% nominal interest rate.
What?
So you're going to want just that language. 1% each month for a year, 12% nominal. That's what we're going to figure out what. Next, we're going to look at annual return to compare it. Okay. So 1% a month for a year, that's 12% nominal, which is not super accurate, as you're going to see next. We're going to jump to 3. In 1 year, how much interest did we make?
126.8 or
Yeah.
$126.80.
It's right there. So 126.83 for 1 year. So we're going to see what percentage of the balance that was. So 126.83 divided by 1,000 is 12.683%. And right now you might be thinking, whoa, dude, Mr. Mack, you just said it's 12% nominal. That's true. 1% a month, each month for a year is 12%. But look at what actual is. This is the actual, or also known as the annual return. This is the percent, so you're going to want to write down like this whole thing right here in your notes because you're going to use this. Maybe even on today's cool down. I don't know. I mean, maybe I do know. Yep. So the term annual return refers to the percent of interest an account holder could expect to receive in 1 year. So it's how much you actually make. So do you think they actually make 12% or do you think they actually make 12.683%?
12.683.
That's what we just got it, right? We got the interest, we divided it by our original value, right? So if you were the bank, would you advertise the 12% return, do you think?
Yes.
Or would you advertise the 12.683 actual?
That's more.
Yeah, you should. If you want people to put money in your bank, right, you're going to want to advertise that because it looks like they're going to get more money, right? Or you could say 1% per month, but 1%, does that sound like a lot or not a lot?
No,
Not a lot. So if you're thinking like, hey, man, I want someone to pick my account, this one right here, baby, that looks like the most, okay? And that's why you will see things like on a sign, maybe you recognize, or junk mail. It gives the letters APY at the end of a percentage places. So the actual percent, like given, because the taking compounding out, is different than the percentage once compounded. So you want to look for that APY, annual percentage yield, to know what your actual annual is.
Wait, so what's the difference between nominal?
So nominal would be like if I said it's 3% interest, okay, and it compounds quarterly, 4 times. That's 12%, right? So that's you could say annual 12% interest, but the adjusted yield for interest because of the compounding would make it a little different. So the APY, this one is the more real number. The other one's not wrong saying 1% a month for 12 months is 12%, right? It's not wrong. It's about understanding what it says. Because if you're going to take a loan and have to pay them back, right, you don't want the higher one, you want the lower one. So they could manipulate stuff and still use correct language and math.
So what's the point in having nominal?
It still is. It just isn't the actual. It's 1% a month for 12 months, which is 12%, right? So you got to, when you read an advertisement, when you sign up for something, make sure you read what it is you're getting into. Okay, I'll show you an example like from Lake Michigan Credit Union in a second. Okay, so but so the big thing here is why is it more than 12%? If it's 1% a month for a year, which is 12 months, 1% 12 times, why is it more than 12%, Finn?
Because the 1%, every time you use the 1%, it's a bigger number.
Yeah, it's compounding each month, right? So each month it's 1% of a bigger number. So a lot of things in the real world compound each month, each quarter. Okay, so it changes what happens with the percentages. It's important, right? Okay, and we're going to wait till you see tomorrow some things that we're going to do. So that's the big idea. Do you guys see that this is the same as the scaling the picture up, 10%, 10%? That compounding thing made it a bigger percent, okay? In a second, when we're done here, I'm going to go show you like a bank advertisement to where you can see where they reference this. All right. You're going to do your lesson summary. I'm going to look up that bank thing for you.